Hi guys, this is Homestuck and welcome back to our AS Pure Maths series. In this video, we'll be looking over chapter 2, which is quadratics, and we'll be covering this in just 40 minutes. The video starts off fairly simple, however it does get harder further along into it, so I have put timestamps down below for you to skip onto different sections. So let's get started. So for these first sets of questions, it says solve the following equations by factorization. Now for part A, it has x squared minus 2x minus 15 equals 0. Now what we want to do here, we want to actually factorize this x squared minus 2x minus 15 into two different brackets. So first of all, let's open up two brackets. And that's going to equal 0. Now for this x squared, we're going to have to think of two things which are going to go into both of the brackets and then times together to make x squared. Well, on both of them, it's going to be x and x, because x times x is x squared. Now for this minus 2x and this minus 15, we have to think of something which is going to times together to make minus 15, but then also add together to make minus 2. So first of all, let's list out the different factors of minus 15. So we've got minus 1 and 15. We've got 1 and minus 15. We have minus 3 and 5. And we also have minus 5 and 3. Now, which of these adds together to make minus 2? Well, it's not going to be that one. It's not going to be that one. It's not going to be that one. It's actually going to be minus 5 and 3. Doesn't matter which order we put it into the brackets in this question here, because there's no coefficient of the x. So we're just going to do minus 5 here and then plus 3 here. Now for this next section, we have to think, how are we going to times these together to get 0? Well, we have to treat them both as if they equal 0, because to times anything by 0, you're going to get 0. So first of all, let's write out x minus 5 equals 0 and x plus 3 equals 0. Now you don't have to do this every single time. However, just to show you this time, it does make it a lot easier. Now we're just going to now add 5 to this side. So we've got x equals 5. And then we've also got x equals minus 3. And there we go. That is our answer. So what we can write here is x equals 5 and minus 3. And that's your final answer there. Now for this next question here, it says x squared equals 9x. Now what we want to do here, we want to move all of the x's onto one side. So let's actually move this 9x onto this side here. So we're going to have x squared minus 9x equals 0. Now what we can do here, we can actually factorize x because x appears in both of these terms. So if we put x on the outside and then we open up a bracket, we're going to do x times x equals x squared. So we're going to put x there. And what times by minus 9 and x equals times together is going to be minus 9x. So we're going to have a minus 9 there. And that's going to equal 0. So first of all, we can work out this bracket here, just like the one above. So we can do x minus 9 equals 0. So we can plus 9 to both sides. There we go. So we got x equals 9. Now there's also going to be another option here with this x. So treat it as it's the same as this x minus 9, but instead we don't actually have a number to take away or add to it. So it's literally just going to be x equals 0. So two options here are actually going to be this one here and this one here, and that's going to be answers there. So x equals 0 and x equals 9. Now there are two different methods for this, which you may get asked to do in the exam, or you may just find them easier. So what we're going to do is we're going to do this first method, which is called completing the square. Now for completing the square, what we want to do is we want to take down this x, and then we want to halve this coefficient of x here. So then we get minus 1. And then we put a brackets around that, and we put a squared there. Now, what we have here is we have this minus 15 on the edge. So we leave this minus 15. Then we also have to do here is we have to square this minus 1, and we're going to have to take that away as well. So we're going to square this minus 1, which is actually just going to be 1, and we're going to take it away, which is going to be take away 1, and that is going to equal 0. So then what we're going to do here is we're actually going to plus all of this bit outside the brackets onto the other side. So we're going to get x minus 1 squared equals 16. Now what we can do here is we can actually square both sides to get rid of this squared here. So it's going to be x minus 1 equals plus or minus 4. Now what we can do here is we can plus the 1 on this side and add it to this side. So we get x equals 1 plus or minus 4. And that's our answer there. So the answer could, if you want to write it out a different way, you could get it being 5 and minus 3. And there you go. That is our answers there. Now, there is a different method to do this one. So if you have a calculator, which is the Casio FX991EX class whiz, and that should be the white one, you can go all the way along when you press menu, all the way along to equation/function. Now, if you enter on that one there and you press polynomial and you select the degree 2, you can then put in this x squared minus 2x minus 15 into the option there. So you're going to put 1 for the first bit, the minus 2, and the next bit, and minus 15. And then as you see, you'll get the two different answers for x, which are going to be 5 and minus 3. And that's a nice quick way if you're doing that. If you want to do it quickly in the exam, it does save a lot of time. Now for this next bit, we're going to be doing a bit more completing the square. So let's first do this question here. So we're going to want to bring the x down and then half this number here. So it's going to be x plus 4 squared. And then we're going to want to take this this plus 4 squared away. So it's going to be take away 16 equals 0. And then we can work out now by adding 16 to either side. So we're going to get x plus 4 squared equals 16. And then we can square either side. So we get x plus 4 equals plus or minus 4. And then we can take away the 4 on each side. So it's going to be x equals minus 4 plus or minus 4. So either the answer is going to be 0 or minus 8. So 0 minus 8. And that's your two answers there. So for this next question here, it says write 3x squared plus 6x plus 1 in this chosen form here. And we're going to find that p and q and r are all integers which we're meant to find. So what we want to do first is we see that we have actually got this p here is going to be the coefficient in front of the brackets. So the rest of it is actually the same apart from this coefficient in the front. So let's actually take out 3 from this bracket because it's the only thing which is in front and the coefficient of the x. And then we're going to put x squared in here. They're going to think what times is by 3 to make 6x? Well, that's going to be 2x. And what times is by 3 to make 1? Well, that's going to be a third. And we're going to close this square brackets there. Now for this next step, what we're going to want to do is complete the square in this bracket. But we leave this 3 and the bracket on the outside. Then we open up a little curly one here. And then we're going to complete the square here. So what's going to be half of 2x? Well, it's actually going to be 1 for the coefficient. So we're going to do x plus 1. And then we're going to put the squared there. And then we've got this plus a third here. But then we're also going to have to take away 1 squared. So let's just take away 1 there, and we can close our square brackets. Now what we're going to do is we're going to times these bits here outside of the curly brackets by 3. So let's do 3, and then we can use our curly bracket there, x plus 1 squared. So we've actually just got rid of the square brackets here. And then we're going to plus, and then 1 over 3 times by 3 is going to be 1, and then minus 3. Now we can simplify that out. So we actually have 3 brackets, x plus 1 squared, take away 2. Now if we look at the question here, we've actually got p, and p is going to be 3. And then we've got q, and q is going to be 1. And we've got r, which is going to be minus 2. So we can actually write that out here. So we've got p equals 3, q equals 1, and r equals minus 2. And there we go. That is our answer there. Now for this next question here, it says, by completing the square, find the turning point for the graph with equation y equals 2x squared plus 6x plus 3. So what we want to do here, we want to actually work out what the turning point is. Well, if the graph looks somewhat like that, the turning point is this bit here. It's going to be the bit where the graph changes its direction. So first of all, let's actually try and complete the square for this bit here. Now we're going to treat it exactly the same as we've done it before, even though it's in a graph. So let's take the coefficient of the 2 out and put the square brackets in. So it's going to be x squared, and then half of 6x, which is going to be plus 3x, and then half of 3, which is going to be 3 over 2. And then we're going to complete the square for this bit in the middle here. So we're going to get 2, and then square brackets, and then curly brackets, x plus 3 over 2 squared plus 3 over 2, and then we're going to square this bit here and take it away. So it's going to be take away 9 over 4. And then we can close our square brackets. And now we're going to want to times the bits on the outside by the 2. So we can get 2 and then curly bracket x plus 3 over 2 squared, and then plus 3 and minus 9 over 2. We can simplify this bit out, so we actually get 2 bracket x plus 3 squared, 3 over 2 squared, and then we can add these bits together, which is actually going to get us minus 1.5. And we can also just change the form of this, so we actually both have 2 decimals. So it's actually going to be 2x plus 1.5 squared minus 1.5. Now, that's actually our point of it already completed. We don't actually have to solve it for finding the turning point. We've now got these 2 bits here. So this is technically what we're going to use as our y point, this bit here. And then we're going to use this bit here for our x coordinate of the turning point. Now, as we've done before in the video, with the x, we've also, when something's inside the brackets, we've got to treat it as if x plus that 1.5 equals 0. So it's actually going to be the negative 1.5. So for the x bit here, we're actually going to get the opposite sign of what's in the brackets. So we're going to do, for the x coordinate, we've got minus 1.5. And then for the y coordinate, we actually have minus 1.5 as well. And that is our final answer for the turning point there. And now when we look at this next question here, it says solve the equation. This is going to be the same equation as the one above, and leave your answers in third form. So we actually can just take it from how we've done it already. So We don't have to do the completeness square or anything again. We've just got this 2 and then the x plus 1.5 squared minus 1.5. Now it's just continuing on. So this is the actual steps if you wanted to solve it and find out the value of the x. And then we're going to say that equals 0 because we've got this equals 0 in the end here. So we've got 2 and then bracket x 0.15 squared. And we can plus this on the other side. So we get 1.5. And then we can divide it both sides by 2 first. So we get x plus 1.5 squared equals 1.5 divided by 2. And then we can square root everything here. So we're going to have x plus 1.5 equals 1.5 and the square root of that. Now we can put that in our calculator here to find out what the square root of that's going to be. So 1.5. The answer for that is actually going to be simplified out is going to be equal to root 3 over 2. So we're going to have x plus a half equals, well, it actually should be plus or minus root 3 over 2 because we squared it. So it's going to be plus or minus root 3 over 2. And then we're going to take away this 1/2 here. So we get x equals minus 1.5 plus or minus root 3 over 2. That's our answer there. It's a little bit squeezed in the end there. But that is our final answer there. So for this next question, it says sketch the curve of y equals minus x squared plus 6x plus 7 while showing all the intersections of coordinate axes and the coordinates of the turning point. So it's quite a long-winded question. However, it does tie a lot together of what we've learned already in this video. So I've already drawn out this little table here so we can input that in them already. But first of all, let's try and find the roots of where the curve is actually going to cross the x-axis. So what we want to do here is we want to factorize this top bit here. So we're actually going to want to put minus x in one of the brackets because we've got a minus x squared. And then we're going to put x in the other bracket. Now we need to think of something which is going to times together to make 7 and add together to make 6. So it's going to be 1 and 7 in them. However, we're going to want to have minus 1 in one of the areas here. But we can, as we see, we've got a minus here. So what we're going to times in this one is going to make it a minus. So we can actually just put the 1 in there. So we're going to put plus 1 in there. Because when we times that out, it will actually make a minus 1x. And then we can do the plus 7 here. And now if we expand that all, it should have the same answer as this bit here. So we do know that's all right there. Now, for this next bit then, we know that if we put this and set that as equal to 0, we can do minus x plus 7 equals 0. And then we can plus x to either side. So we actually get 7 equals x, or x equals 7, if you prefer that way. And then for the next bit here, we've got x plus 1 equals 0. And then we can take away 1 from either side. So we've actually got x equals minus 1. And we know that these two bits here are our roots. We can get rid of everything else. If you've written that all down nicely. So now we've got our 2 roots here, which we can then move up neatly over here. Just get rid of that and put that there. Nice. Now for this next bit here, we've already got our roots here of the x. So we can actually put our roots in here. So it doesn't have to be completely accurate because it's only just a sketch. However, as long as we mark our points, so we can say that's -1, and then we've got here 7. As long as we mark it, it just helps the examiner see where we're putting our answer, and there we go. It shows that we know where these points of intersection are with the axes. Now, for this next bit here, we're going to want to work out what the crossing point of the y-axis is, so the y-intercept. Now, the y-intercept is always going to be the bit which is going to be the plus and number on its own in here. So it's going to be this +7. So it's always going to be the bit, even if you get the your curve in brackets, it's going to be the thing which is times together to make that lone number on the end. So for example, if we had x plus 3 times x plus 9, it's going to be the thing which is going to be 3 times 9, which is going to be 27. So our actual y-intercept is going to be 27 for that answer there. But in this question, it's already expanded out for us. So we just know that the y-intercept is going to be +7. So we can actually do this bit here, and we can mark our 7 on there. Now, what we know is because this is a minus quadratic, and with quadratics, they actually have either a shape like that or a shape like that. Now, if it's a plus quadratic, it will have the shape like that. But because it's a minus, it's actually going to have the n kind of shape. So it's going to be this shape here. So we can cross that one out there. And we know it's going to go through this point, go through that point, and then come back down through this point. So we can actually begin to sketch it already. So we do that in a nice different color there. So it's going to go through that point, go through that point, and come down through there. That's a bit squiggly at the top. However, the turning point is going to be this point here-ish. You can obviously find out the turning point before, that does also help. But if we now can find out the turning point from completing the square, then we can see and complete this diagram here. So let's first of all now try and complete the square. So we're going to take out a coefficient of -1. So we can just do a minus there and open up a square bracket. And then it's going to be x squared, and then it's going to be the reverse sign. So it's going to be -6x and then -7. And then we can open up the curly brackets. So we've got the minus on the outside, curly bracket, and then x and -3 squared, and then -7. And then we're going to take away this number squared. So we're going to take away 9, and we're going to close it there. Now we're going to times everything on this bit by the bit on the outside of the brackets. So that's actually just going to be reversing the signs again. So we get x, then we get minus, and then x -3 squared. And it's going to be +7 +9. And that's going to actually equal +16. So it's going to be minus x and then -3 squared +16. Now, what we can see from our turning point is it's going to be the opposite sign in here, as we said before. So it's going to be 3 for the x coordinate, and then it's going to be the same sign here. So it's going to be 16 there. So our turning point is 316 from for there. And we can see that does actually line up with our thing here. Obviously, it's not to the same scale. It doesn't have to be to the same scale. Obviously, it looks nicer, but it doesn't matter in the exam. So we've got 3 here and 16 here, technically. And our turning point, if we just want to label it here, is 316. And that is our final answer for the question there. So what we've done here is we've shown all the intersections with the axes. So we've shown this one here, this one here, this one here. And then we've also shown the coordinates of the turning point whilst drawing the sketch of that whole diagram there. So that's everything done for that question. Now for this next section of the video, we'll be looking at the discriminant. Now the discriminant is something we come across a lot at A-level. However, we're going to be looking at the basics of it just for this video. Now, what we're going to see here is that we've actually got our quadratic formula screen. Now, this quadratic formula, you might normally use it to find out roots of quadratic. However, we're going to be actually zooming in just on this b squared minus 4ac section. Now, if we have a quadratic equation, so for example, if we have 3x squared plus 4x plus 5, we actually have the values of a, b, and c. So we can still plug it into this bit, but we're just going to be ignoring the stuff which isn't this b squared minus 4ac. So let's actually work out our a value, our b value, and our c value. So our a value is going to be 3, our b value is going to be 4, and our c value is going to be 5. Now, if we sub it into this b squared minus 4ac, we've got 4 squared minus 4, and that's going to be times by 3, and then also times by 5. Now, if we sub that all into our calculator, we're going to get 16 for this bit here, we're going to get 12 for this bit, and we're going to get times that by 5. So that's going to be 16 take away 60, which is going to be minus 44. Minus 44. So we've actually got the meanings of this down here. So it says for f of x, and then the form of a quadratic, so this form up here, what we've got, it says the discriminant, which is b squared minus 4ac, if that is greater than 0, then f of x has 2 distinct real roots. Now this can be used in a number of different ways, but first of all, let's just imagine it as in the curve of a quadratic. Now, 2 distinct real roots would actually mean that the curve of the quadratic hits the x axis twice, as you can see, as it has 2 different roots, and the roots can be the points where y equals 0. And then, if for the next one it says if the discriminant is equal to 0, then f of x has 1 repeated root or an equal root. So this would be on the curve where it hits it and bounces back off again, as it has either a repeated root or the same equal root. And then it also has the next one, which is if the discriminant is less than 0, then f of x has no real roots. And this is where you will have the curve, but it will actually not hit the x-axis at all, and that would have no real roots. And as you can see from our minus 44 value, this is going to be less than 0, so therefore our curve is not actually going to hit the x-axis. So that's just the basics of discriminant. Obviously, we're going to see a lot more of this coming up in future chapters. However, this is just a nice little introduction to it. Right, so we actually have a question here about the discriminants. So it says, find the values for k for which f of x, which is x squared plus kx plus 9, has equal roots. So what we're going to want to do here is we're going to actually want to sub in our values of the coefficients into this b squared minus 4ac. So we know that our a value is equal to 1, our b value is equal to k, and our c value is equal to 9. So what we want to do is we're going to do k and then square that, and then it's going to be 4 times 1 times 9. So then what we know now from that is it can be k squared minus 36. And it says this has equal roots. So equal roots is where it's going to hit the curve, but it's going to hit it once. So that means that we're going to have that is equal to 0. So then knowing that this is equal to 0, we can then actually add 36 to the other side. So we have k squared equals 36. And then we can square both sides in order to work out the value of k. So if we square both sides, we get k equals, and then it's going to be the square root of 36, which is actually going to be plus or minus 6. There you go. We have found the values of k. So that is our final answer there. Now for this next question, where we're going to find out that f of x, where k is a real constant. And we're going to look at part A here, which says, find the discriminant of f of x in terms of k. So if we want to find our discriminant, we're going to find out this b squared minus 4ac. I'm going to find out what subs into here. So our b value is going to be this k plus 4. So we can put k plus 4 squared. And then we're going to do minus 4 times our a value, which is 2. And then times by our c value, which is k. So first of all, let's just expand this double brackets here. So we can just do the expansion here, or we could just find out that it's going to be k squared plus 8k plus 16. And that's going to be taking away 4 times 2 times k, which is 8k. So then we can find out here that the k's are actually going to cancel because we've got 8k take away 8k. So it's going to be k squared plus 16. And that is the discriminant of f of x in terms of k. Now for this next question here, it says, hence or otherwise prove that f of x has two distinct real roots for all values of k. Now when it says hence, we normally want to use our answer from the previous part, but we'll get onto that in a minute. So what we want to do, we want to find that this f of x has two distinct real roots. Now when it has two distinct real roots, we know that the discriminant is greater than 0. And we know that our discriminant from this previous answer is k squared plus 16. And we're going to say that is greater than 0. Now what we have to do, we just have to prove that this is always going to be greater than 0. And what we want to zoom in on is this k squared. Now when you square any number, no matter if it's a positive or a negative, it's always going to make a positive number. So no matter what this k is, it's always going to make a positive. And then when we plus 16, it's also just going to help our cause and add a 16 to our positive. So there we know, from that, we're going to say it is always positive as k squared will always result in a positive. And that's our final answer there. Right, so for this next question here, we're going to be looking at quadratic modelling. Now the question says, a paper aeroplane is thrown over level ground from the top of a tower, and the height in meters of the aeroplane above the ground after t seconds is modelled by this function here. Right, so what we want to know here is that because it's a quadratic, and we're going to know that this equation here is a quadratic, we can actually model this into its own kind of curve. So what we can do, we can just do a very rough sketch here. And we know that if it's going to be thrown from somewhere, it's going to go up like this and down like that. And it's actually a quadratic curve. Now, if we were doing this normally, we would do the little finish off the curve here and it would go like that. But just because we know that it's thrown forward, we know it's actually not going to go behind this y-axis. So what we want to know here is we want to know this point here. And we're going to want to work out this point here as well for the equation. But let's first look at this question here. It says, interpret the meaning of 12.25. Now let's just imagine this is purely a quadratic. We know that this number on its own is actually the y-intercept. So this is going to be this point here. So that is 12.25. Now what we can say here then is that 12.25 is the height of which the paper aeroplane is thrown. Now that is also could be the top of the tower. So you could say is the height of the top of the tower. So for this next question, it says after how many seconds does a plane hit the ground? Now we know here that we want to actually find out the point at which the curve hits this x-axis, as that is where it's going to hit the ground. So we can use this equation and we're going to work out the solutions of this. So we're going to set it to 0 and work out the values of t. So I'm going to assume you can all just put this into your calculator. If not, you can all use the quadratic formula. But I'm just going to put it into the calculator now just because it saves a bit of time. So we're going to work out now that the two solutions you get are 3.679 to 3dp, or minus 0.679 to 3dp. There you go. Now, what we know here is that this is actually going to be a positive value because it's not going to be a negative time it's going to hit the thing. So we know that t is not going to be this value here. So we can actually cross that value out. So we know that this time here is the time that it's going to hit the when it's going to hit the ground. So after that many seconds, it's going to hit the ground. So we know that the values for t is either that one or that one, but we know that it's going to have to be a positive number because it's the time. Now for this next question, it says write h of t in the form that a minus b, and then brackets 2 minus c squared, where a, b, and c are constants to be found. So what we want to do here, we're actually going to want to do some completing the square. So what we can initially do is we can find out what we're going to have to do, divide t squared by to make t squared on its own. Well, we can actually take out minus 4.9 from the whole thing and put square brackets around the rest where it says there we've got t squared, and then we're going to want to divide everything in this equation by minus 4.9. So we got 14.7 divided by minus 4.9, and that's going to equal minus 3. So we got minus 3t, and then we've got 12.25 divided by minus 4.9, and that equals minus 2.5. Now we can recognize this as something we can complete the square to. So what we want to do here is we're going to want to split this up. So we leave the 4.9 on the outside, and we're going to want to split this up and open up a new bracket. So we've got t, and then minus half of this number here, which is going to be 1.5. And then we can close it, squared, and they're going to leave this, take minus 2.5. And then we're also going to want to take away minus 1.5 squared. So 1.5 squared is 2.25, and we're going to want to take away 2.25 there. And then we can close our brackets back up again here. Right, perfect. So I'm going to actually clear out this previous bit of working here because we have a bit more room. Right, so now let's move this all over, and we'll put that over here. And let's continue with this. So now what we want to do is we're going to want to add these two numbers on the outside together. So we do minus 2.5 and then minus 2.25. And that gives us minus 4.75. So we've got minus 4.9 and then t minus 4.75. We can close the brackets there. And then we can actually expand this bit here, so then we can get this out of the square brackets. So we're going to leave this minus 4.9 on the outside, open up, leave this as an open bracket here, and then we're going to want to times minus 4.75, and we're going to actually want to times that by minus 4.9. And that is going to give us plus 23.275. So we've almost got our answer here, but we actually want it in this form where it says a minus b and then brackets 2 minus c squared. So what we want to do, we're actually going to want to move this front bit all over here just so we can have it in that same form. So for simplistic reasons, we're just going to pick it up and move it over here and get rid of that plus there. And there we go. We have it here. And we can identify that all of these match up with that. So A is going to be this value here, B is going to be this value here, and C is going to be this value here. Right, so for this next question here, it says, using your answer to part C or otherwise, find the maximum height and the time the plane reaches this maximum height. So if we go back up to our curve here, the maximum height is actually going to be this point here. And we know that that point is our turning point of our curve. Now, how are we going to find the turning point from this answer here? Well, we're going to use this bit here and this bit here. So let's open up a bracket for our coordinates. And we're going to use this bit for our x or our t value. And it's going to be the reverse sign because it's in this function of t. So it's going to be 1.5 for this x coordinate or t coordinate for this question. And then for our y coordinate, we're going to have this bit here. So it's going to be 23.275. And there you go. That is the turning point, or this maximum height, and the time plane reaches this maximum height. So we can then write it out as the maximum height is going to be 23.275 units. I think it might be meters. And then we're going to have 1.5 seconds. And there you go. That is our final answer there. Now that's it for this video. If you found this video helpful, it would be great if you could drop a like and subscribe. And if you need any help with anything, just drop a comment down below and I'll try and help you out.